Hi students, it's Ms. Vernon and I'm back today to teach on lesson P7, which is solving inequalities. When we solve inequalities this time, we're going to be solving inequalities that involve absolute value and quadratic inequalities. That means we're going to have V-shaped graphs for victory and a U-shaped graph, which is our quadratic. All right, let's jump in to just some introduction type questions. So the first question I have for you is I want you to think about what values would make this equation true. Notice that it's an equation because there's an equal sign right there. So as you think about this, very quickly, most of you will get x equals 8. As you think a little more, hopefully you recognize x equals -8 is also a great option because the absolute value makes everything positive. How would it change if I swapped out the equal sign for the inequality below? Well, some of you might say, well, if I had a value that was bigger, because this is the greater than sign, so if I had a value that was larger than 8, it would work. So 9 works and 10 works. Just going to jot these down. And some of you might say, well, because it's absolute value, -9 works and -10 works. -11 works. And so now you start going, well, okay, so there's a bunch of different answers that could work. So this leads me to my third question. What would that answer look like on a number line? So if I inserted a number line here, you guys would probably tell me that you have your 8 and -8 on your number line, and values that are over here work, and values that are over here work. And so writing this answer as an interval notation answer, you would need to tell me that it goes from -infinity to -8, and it can go from 8 to infinity. This symbol right here in the middle means union. That means that the answer could be in this set or it could be in this set. Both are great options. All right, let's move into how do we do this process on a bigger scale? That last one was just looking at different answers. So let's take a look. We're going to use a process called GA. Some students will go, GA, and grab their head and say, oh, they're making us do more math. Others will hear the word GA and think, graph. The first thing we're going to do is graph to get a visual of what it might look like. This graph doesn't have to be perfect. It doesn't even have to be done on the calculator. It can just be a sketch so you have an idea of the direction it's opening. Step 2 is going to be do the algebra. You want to do the algebra as though there's an equal sign, and I know there's an inequality. That'll come back in step 3. Step 3 is figure out your answers. This is when we're going to take into account the inequality and state our answer in interval notation. Let's go ahead and take a look. I've got 3 examples for you today. All right, in our first example, we have the absolute value of 2x minus 5 is greater than or equal to 7. Well, to begin, I'm going to go to my graph and I'm going to sketch the graph of this. Now, it doesn't have to be perfect, but I know that I'm going to have a horizontal line at 7. So 1, 2, 3, 4, 5, 6, 7. So I have a horizontal line here. That's the right-hand side of this. And then I know this is a V-shaped graph that has been dilated. That means stretched or shrunk. So basically, I have a V-shaped graph that might do something like this. Now, if you're unsure, you definitely can jump over to Desmos and graph this. I'm going to just type in absolute value and then 2x minus 5. There is that graph. So my sketch wasn't terribly off. And then we have our other value, y equals 7. Now, it doesn't show up unless we scroll up. There you have it. Now, if you're using Desmos or your graphing calculator, you can just click and say, okay, there my answers are, but we are requiring you to show us the algebra behind this. So next, you need to go ahead and do the algebra. When we do this algebra, I noticed that the absolute value's already been isolated. So I can go ahead and just take 2x minus 5 and set that equal to positive 7. But remember, absolute value can also be set equal to the negative 7. From here, we're going to go ahead and do our balancing, starting by adding 5 to both sides. Next, I'm going to divide by my 2, and I get x equals 6. This is the first of the two a's. I also need to solve the other part, doing the same process, adding 5 and dividing by 2. And when I do this, I get x equals negative 1. So now I'm ready for part 3 of the process, which is the secondary A, or the analyze or find the answer. Well, based on what I just learned, this intersection point is happening at negative 1, and this intersection point is happening at positive 6. Now, I know my graph may not be perfectly graphed, and that's okay. But I now need to take a look at the inequality and make my decision. This inequality is representing the greater than or equal to. All right, so we have a greater than or equal to, which means I want to know when is my graph, when is the V-shaped graph greater than my horizontal line? Well, my V-shaped graph is above or greater than my horizontal line at those parts. And the x values that make those parts are this part, which tells me my answers are the highlighted portions. So when I go to write my final answer, I'm going to state that my answer can be from negative infinity to negative 1. And I'm going to use a bracket. I apologize. I'm going to use a bracket here because it was or equal to. And then I'm going to use that U symbol saying that it also could be in the set 6 to positive infinity. And that becomes our final answer for this first example. So again, I'm just going to recap. We look for where is it true on the inequality. So in this case, it was greater than or equal to, so we cared about above. And then I ask what x values make that graph exist, and that would be the x values that are on the outsides in this case. All right, let's look at another example. In example 2, we have a quadratic. This same process can be applied using our quadratic information. So in this particular problem, I know that this is going to be a U-shaped graph. I can graph this on a calculator and get an idea of what it looks like, but I'm just going to do a quick sketch. I know that y equals 0 is the x-axis, and so I'm got to find these intersection points so that I can determine the final answer. So that was the G part. That's the graphing. We do want to see graphs on your test, so get in the habit of doing those. Next, we're going to head over and do the algebra. For the algebra portion of this, we're going to need to factor, or we could use the quadratic formula, but we need to solve this problem. So when we go to solve this, I always start with factoring. What adds to equal negative 1 and multiplies to equal negative 12. Factoring is the fastest approach to solving a quadratic. When I list these, I know 1 and 12, 2 and 6, 3 and 4. Those are my factors of 12. As I look at these, I know that the factors 3 and 4 are the only ones that are a distance of 1 apart. And because I want it to be a negative 1, I'm going to make the 4 negative. 3 times -4 also equals -12. So now I'm ready to do my factoring. I'm going to go ahead and use the sneaky square. It is the method I'm seeing most of you use right now. We have x squared, 3x, -4x, and -12. Next, we're going to go ahead and factor out what's in common. So horizontally, there's an x, and x times x is x squared. X times 3 is 3x, and 3 times -4 is -4x. Notice that the last box also checks out. So I've now factored this to x plus 3 times x minus 4 equals 0, and I'm going to finish solving by using the zero product property. I set each parenthesis term equal to 0 and solve. X equals -3 and x equals +4. So on my graph, I'm going to label my intersection points, even if it's not graphed perfectly. All right, we're on to the final step, which is determining the answer. To determine the answer, you need to know your inequality. In this case, my inequality is this, and that is read as less than. So I'm concerned about the part of the graph that is less than or below the horizontal line. That's this part of the U shape. And the x values that create that graph are the ones in between our dots. Therefore, I'm going to state my answer as -3, 4, and I'm going to put parentheses around it because it wasn't or equal to. In this case, we only have one answer. We don't have the intersection of two separate sets. All right, I've got one more for you. Again, we start with our initial problem. There's no negative saying that it's going to be a reflected V-shaped graph. So when I go to sketch my graph, I'm going to simply sketch a graph that is a V-shaped graph with a horizontal line. Again, I'm not concerned terribly about the scale. I just know that that's going to form a V-shaped graph, and there will be two intersection points that I need to identify in order to solve the problem. Next, I'm going to start working on the first of the two A's, which is the algebra A. When solving this type of problem, I do need to get rid of the 4 on the bottom, so I'm going to begin by multiplying both sides by 4. That leaves me with the absolute value of x minus 4 is greater than 32. Next, I'm going to work this problem as though it's an equal sign and finish solving to find those points of intersection. X minus 4 equals +32, and x minus 4 equals -32. Adding 4 to both sides gives me x equals +36, and adding 4 to both sides of the other part gives me x equals -28, which tells me that this value right here is -28, and this value right here is +36. Now I know this does not look like that is the right values, but it is because we did our algebra. Now we're ready for the final step of the process, which is the answer. When we go to find the answer, we're going to again look at our inequality. And this inequality is pronounced as greater than. So I want to know, when is my graph greater than or above the horizontal line? So greater than is going to be there and there. Now, I caution you because we are starting to see patterns. If the graph were reflected, you would not end up with two answers. Reflected just means upside down. But this one is greater than, and it is going to give us two sets of values. So we go from -infinity to -28. I'm going to use a parenthesis this time because it was just greater than. And then we're going to go from 36 to infinity. There you have it. Our final answer. In our class discussion today, we'll talk about what happens if a graph is reflected and how does that change your answers. I hope the process makes sense, and I look forward to taking your questions in class today. Have a good day, and we'll talk to you soon. Bye.